In this video, I will be going over the solution to problem 11 on the 2025 AIME 1. Okay, so the problem gives us this piecewise linear function that's going up and down, and then it says that the parabola x equals 34y squared, which is here, intersects this graph at finitely many points. And then we're asked to find the sum of the y coordinates of all these intersections. Okay, so first of all, why is this finitely many points? It seems kind of counterintuitive. This curve looks like it's going on forever, so it should be intersecting these points forever, no? Well, note that the angle in the parabola is constantly growing. So we start small, and we grow larger and larger and larger and larger, until this parabola overarches these top 2 points. So once this parabola grows so wide that it overarches these 2 top points, the top and bottom, then that's when it stops intersecting this graph. Okay, so first, we have to figure out, like, what can we work with, right? Well, let's first look at this line. This line keeps repeating over and over again. It's just moving over 4 units to the right. And we also have the same thing for this line. This line is also repeating over and over. And it's moving 4 units to the right as well. Okay, so for the first line, which is just y equals x, right? So y equals x. And since we're moving to the right by 4 units, then we can say y equals x minus 4k for any integer k greater than 0. Okay, and then we can do something similar for this line, right? Because this is just y equals negative x plus 2. Or let me bring out the negative real quick. Negative x, and then it's to the right here, so we do minus 2 minus 4k. And now we can bring back the negative. So then we have negative x plus 2 plus 4k. Okay, so those are our two, and this is also for k is greater than or equal to 0. So these are our two equations for these two mountain peak lines, right? So now what we have to do is we have to calculate the sum of roots for this line, and we have to calculate the sum of roots for this line. And by sum of roots, I mean the sum of the solutions for y when this parabola intersects each of these lines. So let's do that real quick. Okay, so we have these three equations. So let's first plug in x into the first equation. Then we'll have y minus 34y squared, and then some other stuff added on. We don't really care about that because we can just use Vieta's formulas to find the sum, and that's just going to be 1 over 34. So we have 1 over 34. If you're not familiar with what Vieta's is, if you have any quadratic ax squared plus bx plus c, the sum of the roots is just going to be negative b over a. So and it works for any polynomial. If you just go one coefficient back. So we have 1 over 34 for this line, and then similarly we have negative 1 over 34 for this line, being the sum of the roots, if we plug in x equals 34y squared. These are the sum of the y coordinates where this parabola intersects those lines. Okay, so we have these oscillating 1 over 34s and negative 1 over 34s. But now the problem becomes, where does this parabola stop intersecting this graph, right? Well, so we have essentially two lines here, right? We have a line y equals 1 for all these mountain peaks, and we have a line y equals negative 1. So let's just plug those into the equation of the parabola. So we have x equals 34y squared. And if we plug in y equals 1, then we'll have the point 34 comma 1. And if we plug in y equals negative 1, then we'll still have 34. So we'll have 34 comma negative 1. Okay, so now let's figure out the values of k for each of these lines when they get to those points. K is going to be a fraction, but it has to be an integer like we established. So we'll just round down. So for this first line right here, let's just do 1 equals 34 minus 4k. So k equals 33 over 4, which is about 8. So, and that's for the positive y values. And then if we also do the negative y values, then we get negative 1 equals 34 minus 4k. That's going to be 35 over 4, which still rounds down to 8. So we're good. After k equals 8, this graph will stop intersecting this function entirely. This parabola will stop intersecting these lines entirely. So k equals 8 is our limit. So k equals 8 for this graph. Okay, now what about this line? So let's plug in y equals 1 again. So then we get 1 equals negative 34 plus 2, which is negative 32 plus 4k. So now k equals 33 over 4, so that still rounds down to 8. And that's for the positive y values, right? This is plus y values. Now, what about 34 comma negative 1? So negative 1, so we'll do negative 1 equals negative 34 plus 2, which is negative 32, plus 4k. So if we move the 32 over, then we get k equals 31 over 4, and that actually rounds down to 7. 31 over 4 rounds down to 7, not 8. So what does this mean? Well, this means, for this graph, y equals negative x plus 2 plus 4k, the positive y values will continue intersecting the parabola until k equals 8, but the negative y values stop intersecting the parabola at k equals 7. So this is actually some really key information. So what that means is that we can continue doing this oscillating sum of 1 over 34 and negative 1 over 34 until k equals 7. And then after k equals 7, we only need the positive y value of this graph, because this graph is still going to keep going. And then we'll also use the 1 over 34 for this graph. Because this graph is still good until k equals 8. This graph's negative y values are good until k equals 7, but the positive values are good until k equals 8. So let's calculate that sum now. Okay, so for this graph, we established that the sum of roots was 1 over 34. So the number of integers between 0 and 8 is just 9. So we'll have 1 over 34 times 9. And for this graph, we'll just go until k equals 7, because that's when k equals 7, both plus y's and negative y's work, so we can still work with that. So that's going to be 8 values. So we'll have minus 1 over 34 times 8. And that gives us a sum of 1 over 34 for until we get to this case. So now we just have to figure out this case. When y equals 8, when k equals 8, we have to find the positive value of y. Because when k equals 8, right? So what the problem is going to be doing at k equals 8 is it's going to still be intersecting at the top, but at the bottom it's going to overarch like that. So it's kind of going to look like this. So we still have to account for this point in our sum, but we don't have to account for the negative y values because the parabola has already overarched them, so it's not going to intersect here. So we have to figure out what the positive root of y is for k is equal to 8. And then we'll add that to our sum of 1 equals 34, and then we'll arrive at our final answer. So let's do that real quick. Okay, so let's plug in k, so we have y equals 34 minus x, and from the parabola's equation, x equals 34y squared. So we'll have minus 34y squared. Now let's move the 34y squared over. We got 34y squared plus y minus 34 equals 0. And now we can just calculate the positive root, remember, using the quadratic formula. So y equals negative 1 plus or minus the square root of b squared minus 4 times negative 34 is plus 34 plus 34 squared times 4 all over 68. And now let's simplify that. So negative 1 plus root 4625 over 68. We can factor out the 25, and then that'll become a 5 outside the radical. So negative 1 plus 5 root 185 over 68. And then remember, from our other sum, we still have this 1 over 34 lying around. And so that's actually 2 over 68, right? So we'll just add that to this. So this negative 1 becomes a positive 1 if we just add 2 to it. So we actually have 1 plus 5 root 185 over 68. So that's our final answer. Okay, and it says A, B, C, D are positive integers. Yep. A, B, D have greatest common divisor of 1. Yep. And C is not divisible by the square of any prime. So I think this is our answer, right? So let's just calculate the sum of all these numbers. So 5 plus 185 is 190. And then we have plus 69. So that's 200 plus 59, which is 259. So 259 is the final answer to problem number 11. I hope you found this video helpful. Thank you for watching.